I did notice today that the speedometer cable, or the speedometer itself, is doing like a more professional sound effect. So I'm going to have to dig into that. I suspect it's actually in the speedometer itself, which is going to be a big problem. Hey folks, welcome back to another video. We're going to finally get into this howling speedometer deal from the Magna, which obviously I have already dissected from the bike itself, and we have it over on Dad's old bench. We're going to try to tear into it and see what we can do to lubricate this up, because I'm assuming that grease, you know, from about 1936 is probably all dried up in there. And so taking these off is pretty easy on an old Magna, and typical of these types of bikes as far as the ear goes. You have a couple of ears here right on the top of the triple tree that these studs go through, and they go through this way, of course, so you can actually see the stinking instruments. They have these weird caps that you could use regular nuts on them, but these are nut caps probably for decorative reasons or aesthetics, because naturally you'd be able to see these. This bike didn't come with a fairing or anything, so this was something I think that they just put on to make it look better. 12 mil wrench takes those off, then you can slide this guy out, and you can take these instruments off independent of taking the whole cluster out, which is kind of a pain in the keister, because I believe the connector for it is down underneath the tank. It's a long pigtail line down to the next connector to take this whole thing out. You don't need to do it, so why do it? So anyway, the other side of it here, and if you didn't know this already, this is not an 82 instrument cluster. This is an 83 instrument cluster. The 82 instrument cluster the first year, at least on the Magna, I'm not sure about the Sabre, had an 88 mile an hour speedometer. So if you went over 88 miles an hour, actually it's not 88, it was an 85 mile an hour speedometer. I'm just screwing around with you, as you probably already realize. And so I put an 83 cluster on here because the original cluster was in really bad shape. I have part of it over there because we do have a problem with the plastic cover that goes on the back of this. It broke. I think I replaced that once when I did this conversion over to the 83 cluster. I don't remember, but I will show you that here in a second, what we're going to do about it. And so this is, the tack's the same, everything else is the same, as far as the temperature gauge and the idiot lights and so forth. And that is illustrated right over here. If I can get my fat butt over here between the bike and the lift. So there's your 82 cluster as far as the center part goes. And it's pretty much the same. Now what happened was, when I took this off, the plastic broke on one of the bosses. And I hate it when my boss breaks. So I said, well, I think I have the old cluster, which I did. And I said, there is no plastic back on it. That's when I remembered, oh yeah, that was trash. That's why I had to get another one. I remember doing something with this, but I do not have another one. But on the back of this cluster was a boss remaining from the old one that broke off. So now I have another good condition boss here. And what we can do is we can just cut this down. I'm going to do all this off camera, obviously, and we'll glue it in there or do something. I actually might machine a sleeve that eliminates those altogether, like most of it. Take most of those plastic pieces out. The holes will align them nicely, and then just push through a aluminum sleeve with like a little flare on the end of it so they can't pull through all the way, and eliminate that so that it won't happen again. I might actually make something better than this crappy old plastic. If not, we can just kind of plastic glue this one in or weld or something. So at least I have that. I don't know what I'm going to do yet. But let's get back to the speedometer itself, because this is pretty self-explanatory. These clusters are all pretty much the same. Even the KZ1000s, the Z1, the 900, KZ900, all the clusters are not the same as this, but they're all set up similarly, where you have the wires in the center. You got to kind of put 10 pounds of crap in a 9-pound bag to get all that stuff in and get the cover on. But pretty much the same thing. You'll figure it out if you get to that point, if you're working on one. Let's go over here and take a look at the Speedo. First thing we'll do is just take the back trim cover off, I guess. And not all Speedos are going to have something like this, you know, because if they're encased in a fairing or something, they wouldn't necessarily have something like this. But again, being that this is an open, naked bike type thing without a windscreen or a fairing, they're going to have something to doll it up a little bit. Plus, these two ears are how it mounts to that parts. Those parts I showed you just now, that might come out now. All right, what the hell is holding you in? There it goes. It indeed was stuck on there. I don't know if we got to take this thing apart or not. I mean, can we get in here and lubricate stuff up by squirting shit in there? If we do, it's going to get all over the glass on the inside. So I don't know if we really have a choice not to. So I have no idea what I'm doing here. Which is pretty much self-evident, I think. Let's get the bulb out. This is really typical of all the other ones as well. They have these rubber mounts. You just take them out, but they usually disintegrate. You can get these for like the Kawasaki's and I think the Hondas too, aftermarket. Those are really easy to get. Now this is the trip odometer deal, and these things break a lot too. And if I remember correctly, there is a little tiny Phillips screw inside here that you got to unscrew to pull this off. Yes, exactly. Oh man, everything is just stuck together. There's a rubber thingy here, but I'm not going to worry about that. Let's just get this off first. Now these guys are generally crimped. I do know that. And that is the problem that I had with what I did on the original cluster, is you end up butchering the crap out of this crimping to get inside this thing. I've watched some videos on it. And what they've done is they've said you just kind of go around very carefully and just pop that up a little bit. And then to reseat it, you're just going to have to put it down to a firm surface and kind of tap it back in. I'm thinking of trying to make something, though, that might do that better for us. I just don't know if I can. I've been thinking about this a lot, but now that I got it in front of me, I'm not sure if that's going to work. Potentially shattering the glass either, which, you know, you can send these out too. I could send this out to a speedometer repair place and have them do it, but I don't care if it's not perfect. You know, I just want the thing to not howl. I need the speedometer back on there. I've had the innards of the cable out for a month or two now because it just makes so much noise. So I'd like to have the speedometer working. So let me think about this and we'll come back to it. I know you guys think I'm crazy here, but I just got an idea, so bear with me. I'm going to use this nose picker tool, which is, you know, just a regular tool holder. I'm going to try to get underneath this lip here. This thing is very difficult to get a purchase on except in one little spot, which I have the screwdriver into right now, which you can't see because of my fat hand. So right about there. Now if I can pick up just a little bit of this spot over a little area, like let's say a ½ inch, 3/4 of an inch, I think I can get this nose picker tool underneath there. I don't have a whole lot of this in the chuck, though, as you can see. This this part back here, which is kind of hard to see, let me lean you forward so you can kind of see it, where the speedo connects, is giving me an obstruction. I don't want to undo these screws here for fear of something breaking inside there, because I think that's got it aligned to a gear or something. I don't know. Otherwise, I just disconnect them and let it float around, but who knows. Now, I'm not going to run this under power or anything. I'm not that crazy. I'm going to do it by hand, just put it in neutral, you know, between gears. And if I have this jaws pretty tight actually, but it's in a supported area around this curve here of this thing is actually pretty strong, as opposed to in the middle, you know, it would definitely crunch in. So if I can get enough underneath here, what I can do is I can spin this manually, you know, just go around and use the cross slide and the compound to try to go in and pull back as we go around. We'll use a little bit of lubricant, I don't know, something. If we can do that, we can kind of spread this out evenly. We can spread it out evenly. And the way I figure it is probably going to pop off pretty fast and hard because it'll be like a spring, you know, there'll be energy behind it. So let's see if we can actually get this thing to start working the way we want without pulling out of the chuck. If so, then we'll lay out some towels here, and so this thing lets go. If it does, then we'll be able to not allow it to shatter, which is probably going to happen anyway, but I can't think of any other good way to do this that's going to not damage it in the first place. So I'm going to try to get some of this up here a little bit, get an area where we can get in with this tool, this nose picker job. Like a tire, you know, a tire machine. This is where I got the idea from. I was thinking of a tire machine. You know, it kind of gets underneath the edge and then it goes around. And then once it goes around in the edge, then, and again, you can't see because my fat hand's in the way, but I'm trying to get you a good angle. You know, like a tire machine does. where it goes underneath there. This is what I'm thinking. Sometimes when I think, though, I get into trouble. This is probably going to be one of those times. But if it works, I'll be an internet sensation. Right. Okay, so there's some space there. I pulled more stranger things than this out of my ass before, so, you know, this actually might work. You know, this isn't really a very strong material, and I'm trying to say this right. I'm kind of waffling like Jimbo from Superbike Surgery says, but, you know, it's strong because when it's bent over and it's crimped, you know, it's got forces that hold this thing in this way. But this crimp is not all that strong because the material's not that thick. So you can certainly spread this back out. Otherwise, they wouldn't have been able to crimp it in the first place, even with the machine, without damaging the thing. So it's not fragile, but it's, you know, it's not freaking titanium either. So we may be able to just kind of work this, but I'm going to go ahead and put a towel down just in case. There's also a really good chance that this is just going to break the glass, because what's going to happen is it's going to go around and be putting kind of an angular torque on it, or it may even start spinning once it loosens it up. I don't know. I tried to turn it by hand. There's no way it's going to move. So I could just fracture the glass. I don't know. But if I have to send this out to a place, I will. But I'm willing to give this a shot because, you know, why not? Ready as I'll ever be. But I'm going to go ahead and use some candle wax as a lubricant if I can get it in here. I picked this one out. We don't have the regular candle. We just don't have any of the small ones. I picked this one out because this is how the age that I act most of the time, so I thought that would be apropos for this video. I'm just going to rub some candle wax in here and try to get it so this thing going to pick up some wax. I think wax is a really good lubricant for something like this because it's not runny. Like I was thinking of using WD, or not WD, but 3-in-1, but I don't want it to go in there. I think wax is a really good idea because this stuff is a good lubricant for this. I think I said that already though. All right. Let's go around first, see what it does or doesn't do. That's quite a bit of load on there, that's for damn sure. I may have to go backwards because I think I'm hit. Yeah, I know what I'm doing. That's better. Because we're actually hitting the body. I can see a mark in the body. I'm trying to stay away from the body. Whoop, look at that. What moved? Oh, we moved the whole thing in the vise, in the chuck, didn't we? Crap. All right, reset time. I don't know why you guys didn't mention this before, but what I do have here is a plate on the back side of it, made out of some aluminum, 1/4 inch I believe that is. I put a center in it on the Grizzly drill press, and so now we got a little tailstock support, keep that thing from popping back out. Tell you what, I got the dropsies today like Major League. I keep dropping everything. Let's see what we can do. Probably nothing, but never know. Well, it wasn't a glass. Try pulling back on a little bit with the compound. Smells like birthday cake in here. Not sure why. Like, you know what's happening? I keep losing the spot that I peeled back, and I'm actually like crimping it even more because it's acting like almost like a knurling tool, you know. And then I can't even find my spot again. So I need not sure what I need. I think the concept is good. It's sort of working, but I guess I might have to grind this down a little bit. Let me work on this a little bit more and see. I grounded with the Dremel, and I'm going to stone it a little bit here. Stone, dude! Try to smooth it out a little bit for like burrs and stuff. Mm-hmm. Alright, I got to think about this a bit because I just can't seem to get this to work. I got a little bit more progress. It seems to be working a little bit better now because I locked the carriage. What was happening was the carriage was actually springing back and allowing this thing to come unseated from that lip. Believe it or not. I mean, there's just enough torque on it to do it, because I was noticing when I was operating the carriage wheel down here, this one right there, I noticed it was pushing against me back the other way, and I'm like, well, that shouldn't happen. So I just locked it. And we'll just use the compound and kind of pull at this angle and see what happens. It's definitely moving it. It's awfully hard though, as you might expect. All right, you know what? I'm gonna go for it. Get in there, you 70 RPM. I'm just gonna bump it and see what happens. Because this is just getting too hard for my hands. It's acting like a cutting tool now. I guess not. That didn't work too well. We're over here at the bench of shame. Maybe not, because we are actually getting some spread. It has folded it over a good amount. I'd say at least 50%. So, or rolled it over more than folded over, but that's fine too. Like I said, I can rework this thing. So I think since we're that far, let's go ahead and just use a pry tool and try to work this thing up and go the rest of the way, because now we've got a good purchase all the way around it. You know, before we just couldn't grab it, you know, circumferentially, if you will. We could not grab that. God dang, that is hard there. I think we work hardened this steel. I don't know if I mentioned this before, but I have absolutely no idea what I'm doing besides smacking my hand over and over again in the exact same spot. I don't know if I mentioned before, I have no idea what I'm doing with this. Yeah, this thing is just getting destroyed. There we go. Now we're getting somewhere. Could not get that metal to yield. I had to just about... I was really close to getting a torch. I'm serious. It just would not... There it goes. It just would not freaking yield. I don't know why. I do not know why the thing is so tight in that one spot. Well, you know, I think... I mean, it doesn't look all that good, but... Again, it's a lot of it is, you know, kind of sort of hidden by this thing a little bit at least. And once we get the glass, I get the glass out of here carefully, I can rework this to flatten it out. I'm not really sure. Well, I know how I want to do it. If I had a piece of aluminum large enough, I would turn it to the right diameter and use it as a mandrel and go around doing tappy tap tap, or even steel or something, and then work this in by hand. And I can even heat it at that point because I don't have to worry about damaging anything. We can reform this, probably make it look halfway decent too, and then paint it, you know, or put it back in and then mask everything off and paint it, something like that. I don't know. Yeah, this is definitely not a how-to video because I got no idea what I'm doing, obviously. But at least we got the cover off, and I'll figure out a way to salvage this. I mean, once it's apart, I can do something with it because it's metal, and there's pretty much nothing I can't do with it with metal. You know, I can figure something out. So now what we got to do is figure out how to get the rest of this apart and get inside there and grease everything and lubricate everything up and see what's going on, and we can reset everything to 0. No, I'm kidding. I do wish I knew the accurate mileage based on the old one though, but like for example, when I took the old one off, I did write down somewhere what the mileage was on that old speedometer and what this one was. I thought I put it in the trunk of the sidecar. I don't know if I could find it and you could turn this. It would be nice to turn this to the proper mileage because this was actually a little bit low. It's like about 1,500 miles, 1,800 miles low of what the actual mileage would have been, assuming that through its entire life it had a good throttle cable, yeah, speedometer cable, and it was actually working. Because when I bought the bike, it was not. The speedometer cable was disconnected. So I don't know how long that was the case. I salvaged it and eventually replaced it. But, you know, who knows? It couldn't have been more than a couple 100 miles of anything, you know? Anyway, we'll move on from here at a later time. I got some other stuff to do, so we'll come back then. Okay, we're back. Another day. A nice time at a granddaughter's first birthday party, so that was yesterday. And we're going to get back on this guy. I'm going to take it apart. And I don't know if I mentioned it before, but I have no idea what I'm doing. So we're just going to go through this and see what we can come up with. I think the first thing we need to do is get this guy off, the needle. Put a little piece of tape around there. I'm going to get underneath this guy with this, see if we can pop this off. I would imagine this thing just kind of comes off just with press fit, but you know, I don't know. Got to come off somehow. It went on somehow. Can't believe they would have used glue on it. You may need to go at this from both sides. That will not come off. There it goes. Ha-ha. Ha-ha. Okay. Maybe a couple little scratches on the surface here. I don't know. Now, I'm not sure how this thing gets clocked because I figured there was like a little square or some sort of a detent in there, but it's just a little knurled brass piece. Well, we leave it off for now because we got to take this front plate off, which is pretty self-explanatory. Well, let me move the camera back to where we need to have it. Yeah, a teeny bit of Loctite on there. Okay, well, I can imagine why they would do that. Can't have this thing loosen it up because you can't get at the damn thing. May be able to do all the servicing that we need to do just by taking this off, but yeah, I bet we can. So there's the innards. What's happening, you know, this is bent too. I noticed that yesterday, this rod. I didn't do that. I noticed that the way this thing was in there before, and that's not uncommon. I've seen that before on other ones. You just have to be really careful and kind of bend it back. See, it's not lined up with the hole. I'm not going to deal with that right now because what we can do now, I believe, is take out these two screws and pull this whole assembly out. So maybe we will service it that way instead. Yeah, so that was a good call, I think, to not take those out, putting it in the lathe, because that would have let this whole thing float and would have absolutely damaged that needle. I wasn't sure how it was set up. Whether this was kind of just lined up to some gears in there or what. I don't know if I mentioned it before, but I'm not going to say it again. So what happens here, I don't know, but like when the speedo cable provides an input as far as RPMs goes, what the hell is doing that just horrible howl? We got a little dried grease up there on this little wheel, but I don't think that's going to cause it. A little dried grease here on this little, what is essentially a worm gear on the back side here. That could be it right there because that is directly off of the impulse for the speedo cable as far as the RPMs go. Not impulse, but the driving. Let me go get the cable. I wish I had, you know what? I wonder if I can, I got an idea. Hang on, let me try this. So it turns that little worm right there. It feels okay, like it's not binding up. Could be inside here too, you know, this little bushing, whatever this thing slips through. And I'm not taking this whole thing apart. So when this turns, that drum in there, I don't know, it's not turning with it. Maybe it, I'm not sure how this works. Is that a magnet or something? All right, we're gonna go ahead and drive this with the drill. I would use the Dremel, but it has to go counterclockwise. I do know that for a fact because I've never been able to actually reproduce this, you know, powering with a drill or something. I don't think I can get it fast enough. I think this thing only goes up to about 45 mile an hour when you're hooking it up to the drill, even in high. So we're gonna try it anyway on the bench here, but this is the original cable. I just took it out of the sheath, you know, so it wouldn't drive the Speedo and howl all the time. And so you can see the end of it's got a square that fits inside the Speedo end here, like so, which we've been doing with the screwdriver end. So I took another cable that I just had laying around. It is a speedometer cable. I don't know what it's from. I just use it for whenever I need like a flexible thing. I like to do a remote a pilot screw adjuster, like on a VTX or something. I can make those. And started to grind that off into a square, but then you lose pretty much the outer wrap on this. So that's fine. I ground the outer wrap off and then just used some acid core solder. Made me a little square, and it fits perfect now. So what we're going to do is just drive it on the bench, and I think I figured out how this works. Pretty interesting. Very clever, actually. I wasn't sure how they did that. Try that again. So what happens here is on the inside you can see there's like a clock spring. So this thing here doesn't spin around at RPM. It's kind of a reference. That's what turns your needle, obviously, because that's connected directly to the end here, you know, where the needle gets pressed on. So that is definitely a magnet in here. I think it is, because it's sticking. So it's kind of getting dragged or drug by that force of the magnetic, well, I should say the magnetic force going by it at RPM. And it's calculated out with a certain amount of magnetism and a certain amount of distance from this steel dome here to drag this around against the force of that little clock spring, and then it reads your needle at that certain RPM. So really, that's all this thing does. So we can kind of simulate that by doing this. So it turns it only so far, and then it goes back. You see the numbers right here? Those are driven off that counter shaft right next to it, little worm drive counter shaft that goes up to another worm that connects to the odometer, and then it makes the thing click over. So the reason why I'm showing you this is just my logical thinking capabilities, which, I don't know, they're a little impeded lately nowadays. What is spinning at speed as far as the speedometer goes, driven by the cable? Well, the only thing is this section right here, this right here, and this. And this is a reduction. This is a gear reduction anyway off this worm drive. And then, of course, over here, the same thing. The only place this thing could really be howling is got to be down inside here. So in other words, where this thing penetrates through, there's got to be some dried up grease or something in there. And I bet you that's what's doing it. And it really sounds like more of a sleeve type inside of a bushing type of howl anyway. But you can see there's a bunch of crud on these gears, which is the old dried up grease. Same over here. So what I'm going to do is off camera, I'm going to take just a little bit of like WD-40 and a little brush, like a little paint brush, like a watercolor brush. I buy these little watercolor brush kits over at the grocery store for this kind of thing. We'll clean all that crap off. And I think we're just going to end up dribbling down some 3-in-1 oil down inside this thing and calling it done, because I can't really think of anything else to do. Hopefully that's going to solve this thing. Now, as far as resetting the numbers, you could do that, I think. I'm not sure how they're related to each other. I'm not really sure if you can do it. I guess maybe you can't, because they're connected internally by little cogs. So they all go in the same sequence. I'd have to turn the whole thing, or take this apart. You know, take this part out, which you could do as far as the odometer goes. It's staked in right there on the top, and it's staked in over here. I mean, theoretically, you could get that out and then reset the numbers to where it's supposed to be. And I'm not talking about resetting numbers down to 0 to make somebody think that it's got lower mileage. I'm actually talking about increasing the numbers if I can figure out what the actual mileage is on this thing based on what I wrote down somewhere, the comparison between what this original one was at, the 88 mile an hour speedometer, and this one. I can add that amount in and maybe dial that in. I'm not sure. Probably not worth it, but it's just kind of thinking out loud. Okie doke, nice and clean. And to get all the residue of the WD-40 off, I just used some 70% isopropyl alcohol. I tested it first down here on the odometer, not the odometer, the trip meter. Make sure it didn't take any of the markings off. And it's great. I mean, it works great. Blew it off with some very low pressure air and then put it outside on the back of the truck, just in the sun while I ate some lunch. And she's looking really, really good. So I'm just going to put some grease back on where it was. Just a little Kendall Super Blue, what the hell. Thought about using silicone grease, but sometimes that stuff gets a little hard over time. Wish I did. and then we'll just have this thing greased up a little bit and run it in a little bit, and then we'll dump some of that some of that 3-in-1 in there, and Bob's your uncle or auntie, one of the two. Perfect. The guys that do the repairs on these things, you know, professionally, my hat's off to them, because I tell you what, this is not easy work. I mean, getting this thing apart and stuff, I guess if you know what you're doing. Kind of flood this area, some 3-in-1, let it capillary down into that bushing, whatever the hell it is, I don't know. Work it in, because it's the only thing I can think of. Okie doke, we're just about ready for reassembly here. Well, sort of. We're going to put it back in the case, and then we have to deal with that that bezel, trim bezel, or escutcheon, whatever you want to call it. I straightened this little shaft out that guy said was bent before. It may have been bent before, but not that bad. It may have happened when that guy put it in the lathe, that dumbass, and it came out under tool pressure. I should say nose picker pressure. And all I did was just take, you know, this thing off. I just took a socket, put it on there, straightened it out, tested a few times. Now she's running dead straight. I mean, I could put an indicator out on this and put it in the mill vise, but that'd probably be a little bit going too far. A little bit over anal, but I am resisting the urge to do that. Anyway, I think we're ready. Let's go ahead and get back in the case. I'll do it all off camera because you saw it come out. Then we'll move over to the lathe. I got an idea what we're going to make. What would be a video of mine without some sort of a lathe job to correct some sort of a screw up that I did along the way in the previous clips of the video? Of course it wouldn't be much of one at all. Okie doke, I got this old pulley. Not sure what it's made out of. We'll find out here in a minute. And it's not like a split pulley or anything I can tell. It's an actual solid cast pulley. So we'll turn it down past the bottom of the V-groove, and we'll have a nice flat surface to slip this over. And then we'll be able to use it just to kind of hold it and tap this thing back into shape. Unlike before, we can actually heat it a little bit to make that a little easier. And then just repaint it, you know. So I'm just going to turn it down, and we'll see what we got when we get to that point. Whoa! You know what? Turning a damn chuck. What the hell am I doing here? I tightened those set screws pretty good. Yeah, I forgot to mention it's just on a 1/2-inch bolt because it's a 1/2-inch bore on this pulley. It's got 2 damn set screws. I don't know. Not sure if this is aluminum or that that pot metal crap, but doesn't matter. It'll work. Well, it's not as wide as I'd like it to be, but we can get it just on that edge and start tapping it in. I just really want to get that edge straightened out. And yeah, we'll figure something out with it, but well, that didn't really work out, as you probably suspected. Not that it's so thin, although that is a participatory factor. The material is indeed peanut butter, so I found another pulley that's a little wider. It was cast iron. All I needed to do was be skimmed, and she works pretty good. So I'm just going around this thing kind of tapping it, and trying to straighten it out. It's working pretty well, actually. You gotta watch doing this though, because it's gonna stretch this out and make it bigger. So I'm just making it flat, basically, trying to bring that edge back, which is all chowdered up anyway. I'm just gonna grind this back a little bit and then come up with a way to recrimp it. I have a couple of overcomplicated ideas for that. That's not bad. Got the dents and dings out of it. And I'm pretty sure it has stretched it out. We'll try heating it up. Maybe it'll shrink back, but do that a little bit later. So as I suspected, I tried this a couple times. This has definitely stretched it out doing that. You know, the tappy tap tap. Circumferentially kind of push the steel out a little bit. So I'm going to try to bring that in just with a little heat. Need more heat. Let's see how that doesn't work. A little better. A lot closer, at least. I may work on that a little bit more later off camera. I think we should be able to bring it in. All right, here's where we're at right now. We're pretty much ready for reassembly. Had a couple of bumps in the road along the way, but overall I'm quite pleased with it. And getting that needle back on was a real pain in the ass, and I'll talk about that here in a moment. Now the thing is, I'm not going to paint the outside trim bezel until it's all together. It may sound counterintuitive, but it's going to get pretty marred up, I think, when I go to crimp that back on. And speaking of crimping, I'm going to try some with something I made, which if it works, I'll put a couple clips in on that. But we'll get to that another time. Now the needle. I cracked the needle twice trying to get this back on. It was so tight. And that little brass piece that's connected to that center thing that goes to that magnetic dish, or the thing that responds to that magnet, you know, a little dish-shaped thing, or bowl-shaped thing, that has a spiral in it. And so when you push this thing down, it turns, and then you don't have the right preload on this. It should just come back, as far as I understand at least, and just touch the little pin where it stops. I finally got that, and I re-glued this a couple of times with some super glue, which this is ABS. It's got to be ABS. They always used ABS on this crap back in the day, and super glue loves ABS. I used some this Polyfix accelerator on it, and it's going to bond just fine. It's pretty strong. I touched up the black in there to kind of hide that glue, and also put the red tip back on it with a paint stick. So I think that looks pretty good. I wasn't sure if this was going to read right, because when I tested it right on the bench here, I put this guy back in, and in reverse, the way this thing has to spin, this thing was banging out 60 miles an hour like this. Or actually just a bit under 60 miles an hour. So I said, well, that seems to be reading high, because when I tested it before, it was a little different circumstance. I had the cable in the sheath, and I was driving it from down by the wheel. I disconnected it from the wheel and used the drill here with a little bit attachment. Drove the entire cable in the sheath, and I was getting like 38 miles an hour tops. So there's two potential causes for that. The first of which being that these innards were gummed up as I suspected and looked like they were. And it was reading low, and this thing did read slow when I was going down the road. You know, if you had one of those speed limit signs, you know, that the sheriff's office and so forth puts up, it was like 5 miles an hour off on the slow side. Also, you could have a problem with the cable in the sheath, but that's not the case in this one. That's a relatively new cable, and I've really oiled and lubricated that up very well, so that's not binding up in that sheath at all. So I'm thinking that a combination of things, mostly inside here, was causing that to read low. But since it was reading up close to 60 miles an hour, 60 miles an hour is a mile a minute. So I don't have another stopwatch laying around, because I tried to use my Apple Watch, but it keeps timing out, and I couldn't get it on camera. So what I did was I used on the side of the phone there, you know, when it's counting up like it is right now, for the time of the clip. I let that go to 10 seconds, and then I started it. And then I let that go for a full minute. And it took 16 seconds for it to go 1 mile. Now that should be about right, because it's actually under 60 miles an hour. It's just barely under. So I started at 10, and theoretically, if it was exactly at 60 and this thing was reading right, it would be exactly 1 mile at that 10-second mark in the next minute. So we were at 6 seconds past that, which I think is explainable by the fact that it wasn't quite 60 miles an hour. So I think this is reading correctly. At least, you know, close enough for my government work, you know. So that's where we're at right now, and I'm going to go and get set up and see if we can get this thing at least back together without destroying it, which I'm not entirely sure we can. Now this guy here I made over on the milling machine and used the 3-inch, this is a little over 3-inch, this diameter right here. Used a 3-inch face mill and just plunged downwards a little bit at a time after I traced that diameter, that radius out rather, on this piece of steel. You can see one of them over here I did as a test. And then I matched that up with a fly cutter afterwards and got this pretty close. And then put another cutter in, the fly cutter, at a slight angle, like about a 5 or an 8 degree angle down. So if I use this to push this in, theoretically it should help to get the thing to start down and go inside. But we're not going to be able to do that. I think we're not going to be able to do that entirely with this. I think this will be a finishing tool. I think we're going to have to do this by hand, you know, with a pair of pliers or something. So I'm going to go ahead and get a pair of pliers set up with a couple of layers of tape on one of the jaws that'll be on the front side there, and we'll start bending this thing back. I think we'll go like one side, kind of like when you're tack welding. Alright, so I got that piece of aluminum over there we used in the lathe before with that failed operation. And I got this squeezed in, so it's compressing that rubber pretty good. And that'll help protect it, I think, because it's nice and solid. I think that's clamped in enough now so we can lose the C-clamp. Alright folks, as we finish the hand crimping, as you can see in this accelerated clip, unfortunately my battery and the microphone died, so as we move over to the mill I'm going to have to overdub this. There's a piece that I machined that has like 5 and 8 to 8 degree angle on it, which is kind of just so it won't tend to fold the edge of that bezel over the opposite way. It wants to force it inwards, in other words. And I'm talking about putting it, how I'm going to fixture this essentially. The back of that mill vise has got holes in it where those bolts go through, but they're sharp edges. I don't like that at all. It might dig into the trim bezel face. So I'm going to end up putting a parallel in there. Now the parallels have holes too, but they are tapered and very smooth, so they're not going to tend to dig into that face. So we'll bring you back when we get to that point, and I'll show you what I mean. That's a 1/4 inch tall parallel, and I'm bringing the mill vise up, and I just have it in a random spot around the edge of the bezel, and it seems to be working right off the bat. I get a good feel out of it. I'm like, you know, I think this is going to work great. And you can hold downward pressure into that radius. Remember that radius on this die, if you want to call it that, is exactly or very close to the same as the radius on the body of the speedometer itself. So it just kind of sits in there nice and square because of the radiuses being the same. And I can just move it around and keep crimping over and over again, which I'm going to do in accelerated format here. Then we'll bring it back and show you the semi-finish or finished product. And for all you purists out there, I realize I botched that word. Radii are the same. Rest of the clips will be live audio because I recognize I had a dead battery, so I apologize for that. So let's continue on with the video. It's crushed it down pretty good. You know, there's some splits in this from the removal and reworking process, you know. And as such, it's kind of peeking out in certain spots. So what I'm going to do with that is I'm going to gently just put it in a vise like this and kind of squeeze those in together. This would definitely be a high risk situation for cracking that glass, you know, going across it like this with that kind of pressure. But doing it like this, I was putting a good amount of pressure on that Kurt vise here. And so I'm pretty sure that that is quite crimped. Yeah, I'm just going to go over this a couple more times and then we're going to be pretty much done with this. We'll give it a final test and then I think I'm going to mask it off and do a little painting on it as far as the black goes and see how it looks with the rubber surround on it, see if it hides some of this carnage. Alright, we're back installed. Looks good. Sorry about the glare, but it's just the way it is. And I think it came out real nice considering, you know, what I was working with and the fact that I don't know what I'm doing. We're going to test it here in a moment. I just want to go over this back piece that I just did some work on, and I'll show you some clips of that. This is that plastic piece I showed you earlier that had the boss broke off in it. I ended up replacing that boss with the one I got off the old cluster. But instead of just gluing it square to it, you know, one piece to another, I milled down that old broken boss in the milling machine down pretty low, and then ran, after I centered on it, I used an 8mm drill bit to center on it. I ran a 10mm end mill down into it just to establish a counter bore. And then I took that piece that was broken off of the other cluster over there, and then I took that in the lathe and turned that down after I faced it, you know, nice and flat, because it was all chewed up at the end. And so it was a slip fit, kind of like a press fit into that counter bore, and then just glued it in with some, I almost said crazy glue, I don't make it anymore, some super glue. So that's going to hold really well, I can guarantee it, because instead of butting two pieces together, if you can slip one piece into the other, especially this ABS plastic, that will provide a really good solid permanent fix because you got more surface area. Plus you have a mechanical connection as well. So that worked really well, all back together like I said. And now I'm going to set you up and I'm going to drive this thing from down below downstairs, down at the cable end. I have the cable snaked up through and oiled up and everything like it always has been. And you tell me what it is, because I can't see this. So you tell me what it's reading as, and then we'll take a look at it and discuss it together after I look at the footage myself. One thing of note, I don't honestly remember the exact speed that I was able to generate with the drill from down there, you know, with the cable end. I think I said like 35 and then 45. I don't remember. It was around 38 or 40, maybe 45, but certainly not the almost 60 we were getting over on the bench with that small piece, almost 60 mile an hour right there. So that's pretty damn good considering, you know, what I was dealing with before. Let's see if we can achieve close to that. We should be able to. This drill is certainly going to be able to push that. Let's try it out. Ready? Contact. All right, I'm stoked. I just looked at that footage you just saw, and about 60 mile an hour down there with the same drill on reverse going through the length of the cable. I was not able to get even close to that before. I know that for 100%. It definitely was not close to 60. Like I said, it may have been like 40, something like that. So, you know, we'll discuss this really quick in an outro in lessons learned and things like that, but obviously we had some binding up in there and some old grease, and certainly that bushing where the main drive comes through that the cable goes into must have been compromised as well. Also, one final thing, earlier in the video, I'm editing this out because it's completely incorrect, but originally I said that this rubber here was the appropriate OEM rubber for this. And I knew that one of them was missing. I thought it was the tachometer. This is the correct OEM one. It was on this tachometer. This is something that I made out of an old headlight surround rubber thing where a headlight bulb goes inside of a headlight bucket, I assume, and it comes up as a Suzuki part number. There is a part number visible on it. I'm not going to even worry about it at this point, but I took a look at it and said, I want to make sure I'm right, because I read the part number off and I'm like, I'm not right. This is something I bodged together. So that's what I wanted to clarify. That's why this looks like this, and that's why that looks like that, because apparently you can't get these, or I couldn't at that time. So this is just, it's a damper is what it is. This rubber piece dampens the vibration of your instruments. That's what it does. And you have the two screws that go through the backside that just hold it in place, but those are only in the backside, so it certainly can do this and wiggle around. And that rubber dampens that, so it tends to not damage the gauges and makes them read properly. So anyway, I just wanted to mention that. All right, folks, that's going to be it on this video. I hope you enjoyed it, because I had a lot of fun doing this, even though I had no idea what I was doing. But I think the end product is pretty good. I have not had a chance to test it yet. I will this afternoon. I got to run down to Publix, a little bit further away than the closest Publix, because I got to pick up a script. And so that'll give me ample time to run down State Road 70 at speed, and that's when it typically was starting to howl. And so once we do that, I'll report back at a later time whether or not it was a huge success or a miserable failure. Probably the latter with my luck lately, but maybe not. You never know. My hat's off to the people that do this for a living. Like when you send these gauges into a company and they restore them to original condition. I don't know how they do that, because there's no way I could do it. So I don't want to do these. If you want gauges done, send them somewhere else. I'm not going to do them. And after you watch this video, you probably wouldn't want me doing them anyway, because that's part of the first lesson learned. Nose picker tools are for picking noses, not for cracking Speedos. I thought it might help, but really didn't help at all. And it could have been disastrous. I'm willing to take those shots to see what happens. You know, it's a learning process for me. I think maybe if I had a sturdier tool, it may have actually worked, and if I could have gotten a better purchase on the actual Speedo and the chuck, maybe it would have worked even better. I don't know. But you know, after we took that off and to bang it all back around, and then once I heated it up to kind of shrink it, I think heating it up helped a lot to recrimp it, because that steel, I'm sure, is work hardened from all the stuff that when it was originally crimped, and of course all the crap I did with the nose picker and with the pry tools and so forth. What the end result of all that crimping though is you get these little high spots because there's little cracks in it. I just ground them off with a whiz wheel and my air grinder with a 120 grit pad, and then smoothed it out with sandpaper and painted it. I didn't show any of that. And of course that rubber deal on the back side, that is not the correct one. I was just showing you that. That is hiding it anyway. So it looks good. I think it'll work fine. And I'm happy with it. So I guess that's all that matters. Can't really think of any other lessons learned, except, again, I don't want to do gauges, so I'm not going to. I think if any other ones came up on, you know, something I own, for example, let's say I bought another bike. Let's say I bought a ZRX 12 or something like that. And let's say I needed the gauges done. I'd probably send those out. Now, I'm not going to buy a ZRX 12, nor do I know where one is. Or do I? And that's where our next video comes up. Well, it's not, it probably will be the next video, but there's actually another one as well. It depends on scheduling here. I'm not going to be putting a ton of videos up because I'm not really getting a lot of efficiency of my time. I'm not blaming you guys, but I put a video up and I get 500 views, and it's just not enough result for me to really warrant the work that goes into it. So I'm going to kind of just put them up here and there periodically instead of like weekly or something, because it's too much work. I got a lot of stuff I need to do around the house, and when something interesting comes up, like maybe that, we'll put something like that up on the video. And of course, when I get the toolbox, I'm going to put that up as well, because I ordered a toolbox from Harbor Freight, and it's a 72-inch US General job to replace my rem line. We'll discuss all that at that time. And I'll tell you an interesting story about Harbor Freight, which kind of ticked me off a little bit, but anyway, we'll cover it at that point in time. And then just watch the channel for perhaps another motorcycle repair video. Maybe, maybe not. All right. Well, I guess that's it then. So thanks for sticking around. Thanks for watching. As always, you know, I really appreciate everybody watching and subscribing. Like, share, subscribe, ring the bell. You get notified when I put crap like this up. So as I always say, don't just repair, restore. Thanks for watching, and we'll catch you on the next video. If you don't stick around, you won't see anything on this.